Hi and welcome everyone on this year's first Hungarian Azure Community Meetup. My name is Balázs Somogyi and I'm working at Deutsche Telekom Systems Solutions and have been working with Azure for a good couple of years, mostly on the field of new services development and automation on Azure Cloud. And in this next half an hour, we are going to have a glimpse of what Windows Virtual Desktop is and how we can enable this feature in scope of our business scenario. To show that, I'm aiming to use Azure native services where possible to see how the services can work together and to be able to offer this complex feature. And then our agenda follows with an introduction of the service, the scenario itself, a short demo on the deployment of virtual desktop, and a follow-up section where some advanced user examples can be seen. And for the last section of the event, please, if you could use the Q&A board within your Teams application and gather your questions. And afterwards, I gladly try to answering them as times enables us. Okay. So what Windows Virtual Desktop is? If you're thinking of terminal services or remote desktop services, Citrix, VMware's, VDI solutions, Horizon, whatever, you are in kind of a right direction. So this is also kind of virtual desktop infrastructure solution, VDI. By definition, Windows Virtual Desktop is a remote desktop and app virtualization platform service in Azure Cloud. The service, yeah, it's a client-server based, let's say, and users have a client application browser or an installable application. And by logging in, they can see their published desktops and remote applications they can connect to. The service is generally available worldwide, and then users only need to have internet access and a capable device, and they are good to go. Virtual desktops capabilities. It offers secure desktop access from any device, virtually with any with an internet connection, meaning that employees can use a personal computer at home to access their work. Everything will be exactly where they left it on their desktops, and the employee will have access to all their necessary software and applications, regardless of what model of computer and operating system on their personal devices. Any work they do and the data they save is within their virtual desktop and not on their local device. And this can mitigating the risk of any misplaced works or accidental data exposure that could constitute in a data breach. Actually working on their secure work computer, just using a different device. So Windows Visual Desktop it takes actually three major blocks to describe the service technically. First is the platform service, and these are actually the components for Windows Virtual Desktop services. And the good thing is these are not our concern. These are all managed by Microsoft, in this case by Azure. The second part is resources the customer deploys into his subscription, and it makes up the customer infrastructure, providing the sessions for the Windows Virtual Desktop. We should have a network storage and of course virtual machines as a minimum to use that. And this is where service integrator like DTITS can put value in. The third major block is licensing. So you will need to pay for the resources you use in Azure, as in the second block. And that's naturally the same way as you would pay for any Azure resources in your subscription. Plus, additionally, you need to have Microsoft 365 licensing if you're using Windows 10 Enterprise as session hosts, or traditional remote desktop services access licenses if you are using Windows Server hosts. The platform itself is free of charge. So this is our makeup scenario. Just short, it doesn't take a global pandemic to disrupt the business. So we have to learn responding quickly to any other little unexpected things to support employees in case anything happens, and enable them to work from remote. And yeah, let's imagine that we're part of a team or at a service integrator that is tasked to design a way employees can work in case of such an event, which renders the offices unusable. And usually business come with requirements that employees must be able to use their own devices and internet access, and should have a similar user experience they currently have with their desktops. They need to access their existing work stuff, documents, tools, whatnot. And we also need to be still secure and auditable, and the deployment should take time in hours or days rather than weeks or months. And the team has expertise in Azure Cloud technologies and decides to use Windows Virtual Desktop for this scenario. And in order to fulfill these requirements, I need to plan with an Azure tenanted subscription, because it's an Azure Cloud service. I need to have a virtual network and probably a network gateway to provide a line of sight to on-premises resources like AE files, tools, and directory services for authentication. And this is probably in an Azure region with the shortest latency to the data center the company has. We also need storage space for user profile containers and possible remote app packages and images. We also need our key store for our secrets, and we need to find out how to do the deployment smoothly. And in this section, we're going to see how the deployment procedure could look like in practice. It's a simplified approach to fit in the demo time frame. And yeah, let's say the team did its due diligence and prepared the environment, so we can jump right in the part where the deployment of Windows Virtual Desktop takes place. So that means we already have a virtual network, a subscription, and the tenant, of course, and a key vault with our secrets, and additional storage as required. I'm going to use GitHub as my code repository, and also will use ARM templates to deploy the service, since it's an Azure resource and supports ARM template deployment. And also we'll need to have a couple of short PowerShell scripts to populate some parameters. And for the automated deployment, I'm going to use the Azure DevOps solution, as it provides this integration with both our Azure tenant subscription and GitHub as well. So I'm going to switch over to my browser, and this is the Azure DevOps overview screen. I created a project for these demo purposes, and I need to set up the environment by adding service connections to my subscription I'm going to use for deployment. So this is using a service principal I've created in the Azure tenant, and also the same for my GitHub. So the code comes from our GitHub service connection, and the deployment target is our subscription also integrated. And additionally to this, I also need to store a couple of secrets, like for the virtual machine deployment, I need to have virtual machine credentials, as well as I need to integrate the virtual machines into a directory service, Azure Active Directory, Windows Active Directory. And that also requires to have the proper credentials. So there is a way to integrate the Azure Key Vault, which is a key store, and also an Azure resource. So we are using the service connection for Azure to integrate it, and I can actually just switch over to link secrets from an Azure Key Vault, and I add those secrets as variables as I would like to use from that key vault. So once I have all these things prepared, and I'm going to need to actually create a deployment pipeline. It could be seen in the releases, and for the demo purposes, I've created already a couple, but to check every possible aspect here, I'm going to clone one of it, and actually we can do some edits and a sample deployment. As you can see, I defined two stages for deploying the platform components or platform component placeholders, and the actual VMs which will give the workload for the Windows Virtual Desktop. So let's jump in the first one. It's actually a list of tasks I would like to see in my deployment. So actually there is it's a very good documentation around how to deploy that from code. So actually we need to do a PowerShell one-liner which gives a proper time format for our host pool token, and that's for that we can just go and find ourselves a PowerShell task, and if I add that, then actually we get a screen like that. We can have a display name, and we can add our script, and the script actually comes from our linked GitHub. So just a matter of browsing out which script file you'd like to add here, and this one is the right one. This script does not need arguments, so it just adds an output and sets it as a variable within our pipeline. It's going to be used by the platform deployment task, which is an ARM template deployment. And actually, this has a bit more inputs, like we need to add our integrated subscription, service connection and subscription, and we would like to create or update a resource group in an incremental manner, and which resource group we would like to go with, and the location. And actually we have to define our template also from the GitHub repository, and as well as the parameters. For the parameters, we can have come this from multiple sources. So there's a parameter file specifically for that. I use that for less frequently changing things, like let's say on the platform template. So back to the parameters. So things like descriptions and the type of the host pool, since I would like to do a pooled deployment, and the load balancer type. So these are not frequently changed things, even if I would like to redeploy. And however, there are a couple of parameters that we would like to reuse and able to change. So this come from the pipeline variables section, where we can actually change that as well. So to do a deployment, so number of instances would be fine, and the workspace name. Okay. Good. So back to our platform deployment, and this is where we also need to change the source group. And when everything is there, then we can save it. And before actually doing the deployment, we need to do the same for the other part. First, just a word about what this part of the template does. It actually deploys 2 or 3 kind of resources. We need to define a host pool where the virtual machines will sit and at the workload. We have to define application groups where the access of our Windows Virtual Desktop environment will need to be set up, and we also need a workspace that's actually a container where we will see our published resources. I can just show that. It looks like something like that. So you can have multiple workspaces deployed, and you can see the published apps and desktops in that. Okay, so the next part is actually the virtual machine deployment part. So we are going to populate our host pool with a couple of VMs, and that's also using the same method. We need to have a small script. The only difference that it's an Azure authenticated script, so it does use Azure PowerShell commandlets. So we need to connect this as well to our Azure subscription. But otherwise, the arguments and the ways of browsing the script and parameters are the same. And actually, this is also very similar to the one seen before. We need to change to the proper resource group, and yeah, we're using here a couple more template parameters because of our predefined secrets, which we needed to be in place for our virtual machine deployment. This way, we can also update how many VMs we are going to add here, and what should be the name prefix of each of the VMs. And if we would like to reiterate that deployment or add more virtual machines, then we can do that. Running that again, only need to adjust our variables to deploy more VMs. So as soon as I save, I'm going to be able to create a release from this, which actually includes all my stages and uses artifacts from the GitHub. So it means it will download the most recent repo content from GitHub, and it creates a release. Let's just change the name as well. Okay. Let's run it. That's number 2. Okay, first I'm just gonna deploy the platform part for the demo's sake. So I just need to wait for a couple of seconds to pull up a build host, and it's going to start the deployment. And in the meantime, we can just switch over to the actual output of what the deployment looks like. And for that purpose, I've created a couple more instances just to be on the safe side. So let's see our demo 1 content and the platform part. That means that these 4 resources are responsible for that. So these are deployed in the first stage, and the rest are good old virtual machines, network cards, disks, and availability set. So the portal also allows us to see in detail our Windows Virtual Desktop environment or environments. So in case we'd like to change something in our host pool, our new host pool is being deployed just right now. And for example, we can see here that in this host pool we have 2 machines up and running, and we can check properties and see friendly names, and we can change the load balancing platform or the session limits as we can set the same in our template. For this host pool, we are assigning 2 host pools, one for desktop and for remote app group, because for each type of application, you need to have one specific application group. So if you would like to have only desktops published, then you only need to have a desktop application group. Okay, let's see how it looks like from the end user. And I'm just switching over to this tab. So if I'm going to check through the browser client, so there's a URL which is the same for everyone worldwide, and this is going to be taken care of by the Azure Platform Service to authenticate us and direct us to our published resources. And in this case, that means what we set up in our application groups, and this is our number 1 desktop application group and assignment. So as soon as there are people populating this part, then the access is being granted for this type of application. In our case, it's a session desktop. And so that means first, if we open this URL, then we are going to provide with a familiar login page where we have to add our Azure Active Directory credentials, and after that we get to have access to our desktop, where we again need to add our credentials. Hopefully it's not stopped by the way. Okay. So once we are adding that, we are in there. So actually, this is a Windows Virtual Desktop host within a browser connection, and we can do the same with the client application. Just I showed you before. That's an installable application, and it gives a bit more rich user experience. It's very similar to the traditional remote desktop client found in every Windows versions or every recent Windows versions. Okay, so let's see if how our deployment went. Hopefully I did not mess up with the variables, but anyway, the deployment went out green, so we have our resources intact, that's for sure, and we can go for the release again and deploy the virtual machines to populate the host pool. And it goes the same way and runs through our script and deploys the virtual machines probably without issues. It takes care of the registration of the virtual machines into the host pool, as well as the registration of the virtual machines into the Windows Active Directory to be able to log in by the users and also use the resources. So this should be an integrated part of a customer environment in some ways, depending on how the previous activities went through. Okay, so let me go back to the slideshow. And there are a couple of follow-up ideas which I would like to mention. So as a service integrator, there are tons of value we can add at the customer resources section. And yeah, since the workload is done via the virtual machines, there are plenty of space to offer services like monitoring updates, security baselines, configuration, backups, user profile management, adding FS logics, containerized user profiles, and also distribute custom virtual machine images. In our demo, we were using a normal marketplace gallery image, but we can use a custom built image as well, and we can have application management by remote apps and also assigning some MSIX app attached technology-based also containerized application attach method, and there is also a way to scale up and down and in and out by adding some schedules in the stop start and updates by data created by monitoring. And also we can put a user management identity by offering the directory services themselves. And if we go up one layer, then we can even add infrastructure planning and automation of the prerequisite services, for example, network policy, storage synchronization, and so on. And we may even offer end user devices and so those devices or equipment the people could use in connection with our service. So that would conclude my short introduction to Windows Virtual Desktop and how a way it can be deployed, and a couple of useful links. The demo repository is available in a public repo, and there is a learning path for Windows Virtual Desktop, and there is a new exam for Windows Virtual Desktop specialty. It's not yet active. It's gonna be in beta status in next month. And since every merchant praises his own wares motto, then we are working on within the Magenta cloud that managed cloud service for Azure, which also includes a Windows Virtual Desktop feature. And there is a Magyar Telekom mobil iroda or mobile office by the Hungarian Telekom, which also gives out devices and connects it with the Windows Virtual Desktop. So I hope you had something to ask. So I'm ready to answer that. So the question says, how can it scale? Can I scale up from 100 to 10,000 users in case of a disaster? Well, yes, there are a couple of limitations within Azure, but this kind of scale is supported. But yeah, you'll probably need some methods and scripting behind that, and probably need to have monitoring properly set up. But itself, the scaling can be done since these are cloud resources. Okay, we're also sharing the presentation slides, and yeah, I have the reference material like the repository. I can upload some more documentation to the repo. So someone who would like to deploy it deploy the service themselves can go ahead with the prerequisites as well. So Active Directory and storage and the networking component on the meeting invites and material. I think I had my LinkedIn account, so in case you have any questions, you can drop me that way as well. And again, thank you for participating and watching this short demo. Have a nice evening. Goodbye.